A census is a count or measure of an entire population. A census will provide complete information, but it's often very difficult and costly to perform. Sampling, on the other hand, is the next best thing, and it's going to be a count or measure of only part of a population. Below, we'll look at a few methods for sampling. The best type of sampling that we could do in many cases is a random sample. This is where every member of the population has an equal chance of being chosen. We'll see, though, that in practice, many times this just isn't feasible. A common procedure for getting a random sample would be to assign numbers to each member of the population and then pick one at random. One of the classic examples of a random sample would be placing numbers in a hat and then just choosing one out of the hat. Technology makes generating random numbers much easier, though. Technology can be used to generate pseudo-random numbers. And the reason why they're called pseudo is because calculators and computers by themselves don't generate true random data. Randomness has to be based on some naturally occurring random phenomenon instead. So computers will often use a seed, which serves as a starting point for the random number generation. This seed can be user-generated, such as prompting the user for an input of some kind. Computers can use some other kind of input, though, too, such as the system time, or they can even sample noise from the atmosphere, for example, or use white noise from a microphone to generate pseudo-random data, to generate numbers which are effectively random. Let's assume that you want to choose one person from the population of all Americans. You want to find out if the randomly selected person believes the U.S. should make elimination of nuclear weapons in the world one of its main goals. Would asking one of your friends their opinion on the issue be a random sample of the population of all Americans? Why or why not? All right, so you'll certainly be asking the question of one member of the population. But is that person truly randomly selected? The answer is no, because someone that you're friends with may likely live near you, may have a similar background, education level, and income level as you. So this would not be a truly random sample. Next, we'll look at simple random samples. And you might think, isn't that the same thing as random sample? Well, the only difference here is that a simple random sample is going to be more than one element being chosen. So in a simple random sample, all samples of the same size have an equal chance of being selected. So we want to make sure that all the different possible combinations of n members who could be chosen have an equal chance of actually being chosen. Now, let's take, for example, this case of pulling 2 balls out of a bucket. Now, one way to find the different combinations that could come up would be to do a tree diagram. All right, so in a tree diagram, we start here on the left and branch off into the different things that could be chosen. So we could pick a 2 or a 4 or a 6 on that first pull. Then after we pick one of those 3, we'll want to pick another one. But this is without replacement, which means that after we've picked the 2 here, the 2 doesn't get a chance to be chosen again. The only ones that would remain in the bucket would be the 4 and the 6. And if the 4 is chosen first, that would leave behind the 2 and the 6. And if the 6 gets chosen, that leaves us with 2 and 4. Now, in these types of tree diagrams, what we do is we look at the paths that were taken to get to the ends of the branches. And we record what had been chosen. So for the first very top row here, we would have gone through 2 and 4, so that would be the combination that was chosen. And I'll just write it here on the right. If instead we take the path to the 2 and then go down here to the 6 after that, then we'll have 2 and 6 chosen. And we just want to write all those possibilities that could come up. Now what this will show is that actually each combination of balls is going to have an equal chance of being selected. How do we know that? Because 2 and 4 occurs twice in the what's called the sample space. So there are 2 ways to choose them. And we see that the 2 and the 6 also come up twice in the tree. And finally, the 4 and the 6, they appear twice in the tree as well. So see, every different combination that could be chosen has an equal chance of being picked. So this situation would be an example of a simple random sample. Let's say you wish to obtain data from all people who have undergone a certain type of surgery in U.S. hospitals. What would it take to get a simple random sample of these patients? First of all, we could perhaps make a list of the thousands upon thousands of surgical care providers in the U.S. That's quite a task. Then we'd try to obtain information about all the patients in the past who had the surgery. And one obstacle is, would the surgical care providers even give you this information if you asked? They might not even be allowed to by law. So getting that list of patients put together is really virtually impossible. We would have to then put the patients into a bin or computer database and choose them at random. Now, in many cases, we wish that we could do that, but we simply can't. So I'm going to say this would be virtually impossible to do. So we'll have to use other methods for getting our sample. A simple random sample is often thought of as the best way to select members for a study, but it's just too difficult to do in some cases. So instead, we'll often use other methods for collecting samples.